Okay, I want to talk for just a minute about systems of linear inequalities. You've seen systems of linear equations before. Now we're going to look at inequalities. Now, and before I do that, I want to start off with something simple like this, just an inequality. Now, when we have x greater than 2, and we want to express the solution for that expression, if we are just just working on the number line, like we did in elementary school, what we would do is put a circle around 2 and shade in to the right, a little shaded arrow to the right. But if we're in the context of two dimensions, so we've got the x-axis and the y-axis, if we're in that context, then what we're looking for are not the numbers that are bigger than 2. We're looking for the ordered pairs such that the x-coordinate is bigger than 2. In other words, we're looking for a bunch of ordered pairs, a region. So let's start off just looking at what it would mean to say x is equal to 2. Well, if x were equal to 2, we would have just a solid line here. I put it broken here because we have x strictly greater than 2. So when I shade in my region, I'm not going to want to include that line. But let's just think about what this line would represent. This line would represent all the ordered pairs that have their x-coordinate being 2. So if you look at all the ordered pairs on this line, all the x-coordinates are 2. Now, when we talk about sketching this region right here, we're saying I want all the ordered pairs where the x is bigger than 2, strictly bigger than 2. So what I do is I put a little broken line here where x is equal to 2, and I'm going to shade all the ordered pairs. Now I have a choice. I could shade to the left or to the right. But of course, the larger x values are to the right, so this must be the region here, x greater than 2. So I shade that in. So what I've done there is I've expressed the solution to that little expression there, x greater than 2. Well, this is this region that I've shaded in here. That's that. That represents all the ordered pairs where x is bigger than 2. Now let's do this for y. Let's say y is less than or equal to 2. So now we're wanting all the ordered pairs where the y-coordinate is less than or equal to 2. Now, less than or equal to, that means I'm going to have a solid line. And the choice is, do I shade above or below? Well, obviously below, since I'm wanting the y's to be less than 2. So there I go. I shade it below. Now, let's suppose we want to put these together. I want to shade the region where the x values are strictly greater than 2 and the y values are less than or equal to 2. Well, if you put these two together that we just sketched here and shade where they overlap, you would find this region right here. Below the y less than or equal to 2 and to the right of x greater than 2. So it would be this right here. And that would be our solution region. Now this is a system of linear inequalities. And that solution is the solution region is represented right here by this shading. Okay, now let's look at some that are a little more complex. Let's suppose we've got this linear inequality. And I want to sketch, I'm going to sketch this first. Now, one of the ways you can sketch a linear equation, that's what we're going to do first. Before I do the shading, I'm going to sketch the equation first. I'm going to sketch the line. I like to find the intercepts. I like to let x be 0 and find that what the y-intercept is, and then I'll let y be 0 and find out what the x-intercept is. And I do a quick sketch. So here notice if x is 0, y is -1. And if y is 0, x is 1/2. So it looks something like this. Now, if we were just sketching a line, we would be done. But we're not sketching a line. We're wanting to represent a solution. We're wanting to represent a region where all the ordered pairs have this property. If you double the x, subtract the y, you get something less than or equal to 1. Well, this line represents where if you double the x, subtract the y, you get something equal to 1. So the question is, where do we shade? Do we shade below this line or do we shade above the line? Well, one of the things I can do is I can just pick a point above or below and test it. And if it works, that will tell me which one to shade. And if it doesn't work, that will tell me. So look, let's suppose I pick 0, 0 right here. Okay? Now, if 0, 0 plugging into this linear inequality, if it works, if I get a consistent expression here, then what happens is I know to shade the region that contains 0, 0. But if when I plug 0, 0 in here and it doesn't work, that would mean I need to shade the other region. So if it works, I shade the region from which I obtained it. And if it doesn't work, I shade the other region. So let's see, let's plug in 0, 0. Well, 0 here and 0 here, I get 0, and that's definitely less than 1. So I'm going to shade the region that contains 0. There it is, right there. Done. Okay, now let's try another one. Here we've got negative x plus y less than or equal to 2. So first thing I'm going to do is sketch the line, negative x plus y equals 2. So I'll let x be 0 and I find that y is 2 up here. I'll let y be 0 and I find that x is negative 2 over here. So I sketch that. Now the question is, do I shade above or below? Well, let me test 0, 0. See if it works. If I plug 0, 0 in here, I get 0 plus 0, and that is definitely less than 2. So that means I'm going to shade down here where 0, 0 is. In other words, 0, 0 was just my test point. And it was an easy one. That's why I chose 0, 0. I could have picked, I could have picked 0, negative 5, okay? But 0, 0 is an easy one to test. It works. So that representative point worked, so that means that whole region will work. So I shade below this line. Okay. Now let's put these two together. I've got 2x minus y greater than or equal to 1, negative x plus y less than or equal to 2. Now notice I've got this inequality and this inequality, and I want to know, well, where do they overlap? So I'm kind of putting these two together. I sketch these two lines, and then I decide where the shading goes. Look, I'm above this line. Okay, so I'm going to shade above this one and below this one. And when we put those together, see? So look what I've got here. I've got below this one, see? That one right there, and above this one. See? And when we shade those, we get something like that.